Hey, welcome to the Cell Doctor channel. In this video, I want to give you an update for the Megacell Charger Professional version. I've been working on the menu for the device itself, so you can push the buttons and access different options on the hardware and use it as well. You can set the functionalities like Wi-Fi, set the config for the charging and discharging, but I will show you in a second how that works so you understand it better. You are seeing now the Megacell charger. It has the new connectors, the XS12 connectors, which will be using 6 wires. That includes the temperature sensor as well, with 2 wires for the voltage reading. So instead of 4 wires, we have 3 wires for voltage reading, but that still gives an accurate method of measuring the outside voltage, because I can measure the resistance of the wire and apply the same for the 4th wire. The reason for not including 4 wires is that I still want to keep the reverse polarity protection. In 4-wire mode, it will be more difficult to detect if the cell was inserted properly or not. So I want to keep the same MOSFET for reverse polarity protection, and that's why I had to include this. So let's jump into the menu. Let me zoom in. Let's make this a bit darker. The lines you see on the display, they are not visible with the naked eye. They can just be seen with the camera because of the refresh rate. The first thing you're going to see when opening the device is this main page, where you see all the cells with different charging state, and on the right side you can see the macro idle. That will give you the state of the macros. Macros are functionalities that combine multiple steps together, like measure capacity, that combines the charging to the full voltage and discharging to measure the capacity, then charging back to the store voltage set. So to access these functionalities, you can see that I will be using both buttons. The reset button have been transformed into a regular button as well, so it can be pushed to access the menu. You long push it from the main page, and then you access the operations and the settings submenus. You also have the exit. Both buttons can be used for up and down, so reset, that will become the set button. I will be erasing the maybe, and keep just the set for now, until we make new cases and give it a new name on the case actually. So you can see that pressing the button, the reset button, allows me to go down, and the menu will return to the first when pressing. The function button have 2 operations, so you press it shortly, it will go up, and long press it will go into the sub menu. So in the operations, we have the measure capacity, charge, discharge, store, dispose, stop, and back. When you are on the back, long pressing will get you back. So let's give you an overview of the settings that we have. We have now introduced the chemistry setting. You have 4 predetermined presets that can be used to apply them. If you want to apply a setting, let's say 0.5, that's That's lithium ion 0.5 charging and discharging, 0.5 amps charging and discharging. Pressing will give you this icon that the setting was applied correctly. So it takes a second to apply the chemistry to all the ICs, all the charging ICs, and store in memory the new settings. So these are the main settings. You have the lithium phosphate as well. And to edit one of these settings, you go to the custom preset. This custom will give you the ability to edit the charging voltage, the discharging, the minimum and max voltage as well. So the first thing you can set is the discharge mode. This is the constant current, so entering in this, it will allow you to switch between these three. So you have constant current, constant voltage, this is the CV, and constant resistance. So I usually keep it at constant current because it's much predictable on how the cell will behave, but that depends on the type of testing you want to do. Long pressing the reset will get you out of the mode. So right, I set it to constant current. We have the max voltage. The max voltage can be set by pressing the function button, and then you can scroll, or not scroll, you can move with the reset and the function button to set the voltage up to 4.4 volts. It can be set. So once you set the decimal you want, you can go to the other one and when you exit, so press once, exit, don't move the cursor around, and long pressing again will set that voltage to this menu. You can notice that it automatically made it 4.4 volts. That's the maximum for the charging IC. Each submenu has its own minimum and maximums, so we don't set the voltages wrong with out of the capabilities of the device. So we have things like max capacity. This will be used to finish a process in case it goes for too long. So if you have 3000 milliamp cells, you don't want to exceed a charging of 4000 maybe, so you don't keep charging the cell that has self-discharging or it's shorted. You don't charge it forever, and maybe cause issues on the device as well. So here you have the charging current. CHG stands for charging. I had to use shorter names so it fits within the menu. Same thing here, you can edit it like this. You enter, reset will go down, and the functions will go up, or the reverse will go up with the reset, up in the number you add to the charging current. And same thing here, you can set it to 5000 milliamps for charging, but it will be capped at 4500. So let's leave it, because I don't have that kind of cells. Let's leave it to 2500, so you can also see how it's charging. Alright, I'm gonna exit this. Pre-charge current. This is the current used to pre-charge the cells when they are under 3 volts for lithium ion. Term charge current, it's the termination current when charging will stop. So you can set it with the minimum of 128 milliamps, and it can go up to 2 amps, 2 or 2.5. Discharge current, you can set this one up to 3000 milliamps. Discharge resistance, this is when you're using constant resistance. It stands for 1 ohm. When you go up, it will go up with dividing the resistance. The lowest the resistance, that's higher discharge rate. So if you go to 2 ohms, sorry, that will make the discharge rate half as the maximum. So at 1 ohm, you get roughly 4 amps when you discharge a cell, a lithium ion cell, but we actually had to cap the discharge rate to 3 amps, so we don't burn the circuit, because there's so much heat produced at 4 amps that the circuit will overheat. If you're going to use different fans or different cooling circuit, we might provide that's for commercial users. If they can cool the circuit, not heat, if they can cool the circuit better, we might provide a firmware that will allow you to discharge up to 4 amps, but that will change the warranty terms and stuff like this. So you have the max temperature, that's the max temperature at where discharge or charge will stop, and we have the apply. So let's apply this setting. You can see the confirmation up top. You can go down and click on back, or you can long press the reset, and it will exit as well. So right now, if we go to the main page, you can see custom being written up there. So that means that all 16 slots have the custom chemistry applied to them. You will be able to apply different chemistry to each slot, and that will create a mixed message up there. I plan to add the chemistry on the menu as well, but for now I want to focus on the functionality. So it will be shown somewhere here what chemistry the cell has as well, or I will be making another submenu when sub page. When you click this, show you that page, and then if you click again, exit maybe. But for now, we'll be using the software for the additional customization. I want to make it work with without having to use the software as well. So for those that want to read the capacity on the screen or do all the operations without a computer, they will be able to do that as well. So that's for the chemistry. That's the settings for the chemistry, and now we have the connectivity. For the connectivity, you have the connection status. Right now it's connected to an access point, and you can also see the signal strength, which is 48%. I found that anything above 35 to 40% signal, it's okay to use. Before I didn't have access to this setting. Only when I was setting the access point, I will see the strength, but I also saw that this changes depending on how you position the device, or if you have any blocking objects, that signal can change as well. But this is a good way to see what's the connection status of your device. So another thing that I have added into this menu is start the config portal. So before it was starting automatically when it was booting, and that will take a few minutes to clear out if you don't want to use the device. You will have to wait or set it to a dummy network to avoid, it's not a dummy, set it to your network to avoid that delay. But now I have made it to ignore the start config portal. You can start it manually from the connectivity menu. Let me bring this back. Alright, so that's the start config portal. I will make a detailed video about everything that's under the menu, but now I just want to give you an overview and show you what I've been working on for the past weeks, because it's been like a week and a half since I posted an update on this. So you also have the Wi-Fi enabled or disabled. If you disable this, there's no functionality for the connectivity. You won't be able to use the Wi-Fi, so make sure this is enabled. And you have the save option here to save the settings. Right, so that's the connectivity. Then we have the hardware. Here we have an option for the fan. If we set it to on, the fans, not sure if you hear them, probably not, but the fans will start, and you also see a small icon on the display. Let me exit this. On top here, that the fan is started. You also have another icon next to the fan. Let me check if you see. Yeah, you should be able to see it. Top right, that's the Wi-Fi, and it will change depending on the strength of the Wi-Fi. Okay, so let's get back to settings. You have two options, which is auto. Auto will start the fan when there's a process charging or discharging, or if you set it to on, it will do that. It will keep it on. That's a good thing to use if you want to test the fans or see that they are working fine. Temp, you have two options here. You have the onboard temperature sensors, which are under each cell. Let me make that a bit lighter. Alright, so under C8 there's an IC, which is the temperature sensor, which you can read on the display as well. A bit up there's a smaller IC, that's the temperature sensor for the charging IC. That's like a safety switch for stopping charging in case temperature on the cell or on the board goes too high. So if I change it to accessory, if we go to the cell detail by pressing the function button, you can see up there that we have a minus 54 degrees Celsius or 55. Let's see if yeah, I should be able to see it better now. It's minus 58. And if I plug this cable, which has a temperature sensor at its end, it's connected to the XS12 female, and I plug it in, you will see that temperature being updated to the temperature of the temp probe. And this is great thing for those that want to test cells that uses a different shape than 18650, or if you want to attach this directly to the cell. So if you want to have a better reading directly on the cell, you can use some Kapton tape and attach this to your cell. This will provide you a more precise temperature, because there's no PCB where the heat can get can be disposed like when you're heating the cell, if the cell is heating, some of the temperature can go in the PCB rather than being read by the temperature sensor only. So this is a bit more accurate using the external sensors, but in my testing, and I've tested these cells with up to 3 amps charging and discharging. They get hot. Also, the PCB gets a bit hot from the resistors that discharge the heat. I solved the issue with the MOSFET getting hot as well, because that was getting around 120 degrees, and that's not very well for a MOSFET to be at that temperature for too long, because it can damage the MOSFET and make it unusable. But now with the new discharging solution, I'm using a different IC to set the PWM signal to each channel. So each channel can have its own discharge rate. Right now I'm feeding 5 volts to that MOSFET instead of 3.3 volts, and that keeps the MOSFET fully on, and it prevents overheating of the MOSFET. So now we're still left with the heating produced by the resistors, but using the fans and the heat sinks that we have installed, it manages to keep it at around 120 degrees Celsius at full 3 amps. But 3 amps, I think that will be the top limit. But what I will recommend to users is use it at about 2 amps per cell, especially when using all 16 slots. If you want to use 3 amps, I would recommend using 8 slots, like leave one between each cell. I also plan to have a solution that will allow getting the heat off the board. So instead of using the resistors from the board, I plan to make a small accessory for each cell, or maybe another board which holds the MOSFETs and the resistors for discharging, where we can install some big heat sinks to cool it better, some fans on top or something like this, and that will give you the ability to use the device to up to 5 amps per cell, and that can be useful for some of the cases. But still, right now you can use it in combination. You can use the slots in combination. So if you need more discharge power, you can combine the slots. You won't be able to discharge 16 big cells, like 50 amps cells, because you're combining the slots together. Maybe combine 4 slots, and then you still get up to 12 amps discharge rate for those 4 slots, or combine all 8 at 3 amps, or combine 16 at 2 amps. So it's up to you. Like combining 16 slots at 2 amps, you get 32 amps discharge rate. That's a pretty good test for most of the cells out there. So you'll get the hang of it once you start testing and find the way you want to use your testing. So see, removing the temperature sensor will also set a state that's too cold. Yeah, that's on the left bottom. You see the state of the cell. It's too cold to operate. So you'll see that when it goes under -5 degrees Celsius. I also plan to add Fahrenheit to the menu, so we will be having a small switch, but I want to finish the functionalities, the main functionalities first. Then I will be working on adding some perks to the firmware to make it easier for the folks using the Fahrenheit. So let's get back. So you see I'm pressing to go into the menu to see on the page for a detailed cell. You can go up and down, and I press again to exit that. So here, this one will get you into the menu, and if I go into the settings, If I press too fast on the reset, it will read that as an exit. But after you start using it, you'll get the hang of how to use the menu. So right here we also have the reboot and the shutdown. The shutdown option is useful because it will clean up the device before shutting it down. So you might be using that feature if you want to make sure there's no errors when you unplug the device, because we're using more advanced ICs to communicate with the charging IC, and also to set the PWM. I included this shutdown option, which will reset those devices and have them prepared for shutting down. Because if you are removing the power while those ICs are operating, you might see some flickering lights and on the IC, or you can have the ICs being left on for charging, for example, and when you power on the board for a few seconds, you will see that the cells are charging, but once it boots up, it will stop all the processes. But shut down, it's a clean way to exit. Right, so that's about the hardware settings. Another setting we have is for display, and this is the cycle information. Right now it's set to off, and if I set it to on, and you can notice that each menu has its own save. If you're not saving this, if you're not clicking on the save and hold the function button to save this information, next time you reset the device, it will get the default that's stored there. So you can see that right now with the cycle information on, it will cycle through the cells and stay for 3 seconds and move to the next cell. Okay, so this is about the functionalities, and let's put this guy to work now. We go to operations, and we have one macro for now, but I might create more into in the future, like adding different steps to the macros, because now I have set the I have set my code to allow me to create different actions, different sets of actions in these macros with the state machines and with all the new architecture of the code. It will make it easier. It will make it easy to add new macros directly to the menu. So let me zoom out a bit. See how this starts. Right. Okay, so now I'm on the measure capacity. I hold the function and you see it's starting. If I go to the cell, let's go to the first one. Let me zoom back so you actually see what's up there. Okay, you see now that it's some of the cells are charging with 1.4 amps, and the current will depend on the state of the charge of each cell. So if they are discharged under 3.7 volts, 3.8 volts, they will fast charge. They will use the entire current if they can take it as well. So this one, you can see it's 1.9 amps, I think, if I read that right. This one, yeah. So the charging curve of the IC, it's it's dynamic, so it will depend on the max voltage that's set to the charging IC, and that will follow. Let me get that BQ datasheet to show you what I'm talking about. I actually have it here. BQ. Alright, let me switch that on. Okay. So okay, right here. Let me zoom in. So this is the IC that we're using for charging, for charging each cell. So we have 16 of these. That's why I needed to communicate with each of them, so I can set different chemistry setting to each cell. So you have the regulation voltage, which goes from 3.5 up to 4.4 volts. And that's the step where the constant voltage will be kept on the IC, and you see the curve that on the current, the blue curve is the current. It will go down until it reaches the minimum that's set there. So you see it's 128 milliamps up to 2 amps, 2048 milliamps. So bat short, it's when the battery is under 2 volts, I think. Yeah, you see it here. That's the step where it will charge the cell with 100 milliamps and not more. And then you get to the pre-charge. So this is the bat low, 2.8 to 3 volts. That's the pre-charge. And then you get the fast charge, which goes right here. And then you have the regulation voltage. That will depend on the setting that you have. And you can imagine this scale getting smaller or bigger depending on the voltage that you're setting for the charging voltage. So the same will apply, but it will start, like if you set it to 3.5 volts, the charging voltage, the regulation will start at about 3.4 volts maybe. And it will still follow what I'm trying to explain, it that it will still follow this curve, but it will be applied for the max voltage that you're setting. I actually use this this functionality for the store voltage. If it's above 3.5 volts, the store voltage that you're setting on lithium ion, I set it to 3.7 volts. That's the nominal voltage on lithium ion, and I set that as a store voltage, and I'm using the IC to set the store voltage to 3.7, and it will follow the same charging curve and stopping the charging when the current reaches below 128 milliamps. This will make sure that the voltage will not drop too much when stop charging it, because before we had the TP4056 IC, which was charging with 1 amp per cell, but at 3.7 volts you will charge that cell with 1 amp, and there's no way for knowing what's the voltage actually when you stop the charge. So we had to stop the charge, check what's the voltage, let it run a few more minutes maybe, and then measure again, and that will not make the process very accurate in terms of setting the voltage precisely. Like if you want to precisely leave it at 3 points around the, from my test it's like 10 milliamps less than 3.7 volts, so that's very accurate in terms of having the cell set at 3.69 volts. So you will see it after a while if they're discharging that that the voltage dropped under 3.6 volts, and then you will know for sure that something is wrong with that cell. So that added another layer of accuracy to setting the voltage for the cell as well. One thing you will have to be careful is not setting the wrong voltages, because now we can support up to 4.4 volts. I'm sure that it should not overheat the cells, the lithium ion cells, because the current will go low, and if the cell cannot draw any more current because it's topped up, it should stop. I still have to test that setting 4.4 at a regular lithium ion cell, see what happens, to see if it's any hazard that I should include in the documentation or not. But usually you should read the data sheet of the cell that you want to test and set the proper voltages. I don't want to limit you at 4.24 because you might have some LiPo cells that support higher voltage. So those are the high voltage lithium ion cells that supports up to 4.4. So why not having this option on, and being careful when you're setting the chemistry? That's another reason I included those chemistry settings. So if you're not sure what is the voltage of your lithium ion, if it's 4.24 or 4.4, using the lower voltage will keep you safe and avoid any problems. Right, so this is all the updates that I wanted to give it in this video, and I will keep working on testing the device, because I had some issues with the communication with the BQs, because I was setting each BQ too fast, and sometimes it will not catch the settings I wanted. So I implemented a way to check the settings that have been applied, and that will add a few more milliseconds delay when you apply the settings, or when you start charging and apply the settings for the chemistry. But you're not doing this very frequently, so a second more or less when you're starting a cycle, it's not gonna count. But I had to make sure that the settings were applied right, because I had the issue when it was going into store voltage and the setting was not applied properly, and it will go to the full charge voltage. So instead of setting to 3.7, it will go to 4.24. But after I applied this, I saw that this is no longer happening, and I can move on to the next of the tasks, which are a few more options to add into the chemistry, like cycle count, max timeout for charging and discharging as well. So there will be a timeout settings for that will handle both. And I still have a few things to add until we can move to supporting the charger into the Megacell monitor. Right now I can send commands from Megacell monitor, but I cannot set the chemistry. But the good thing is that even if it will not be implemented until I ship the devices. That will depend on the time available for Martin to add these changes, but it will still be usable because you can set the chemistry from the device itself. You set it from the menu, save the settings, and then you use the Megacell monitor just to send commands to it. The store volt, all the commands that you have available right here. So you have the charge, discharge, MCAP test, that's the measure capacity. You have stop, store charge, and the rest are functionalities from the Megacell monitor. So all the operations that were available in the old device can be accessed still from the Megacell monitor. Right. So I can see the voltage. .3 something. Let me see if I set those settings properly. All right, so I was saying that I should test the 4.4 volts, and I did that by mistakes. When we set the voltage for the custom chemistry, I actually set it to 4. Let me switch that. 4.4 as a max setting. You see, max voltage 4.4. And I see the lithium cells, they are not getting hot, but they are still going at 4.36, which I'm sure that's not very good. So you should be aware of this to make sure you're not overcharging the cells. And I'm going to switch it to 4.20. Right. And you can see that once I apply this setting, most of the cells stop charging because they will reach under 128 millivolts. Some of them actually overcharged. You see a normal charge right here because the voltage is too high. It's higher than the setting that I applied. So definitely this is something I will have to add into the documentation to make sure you're not overcharging the cells like I just did. But they're not getting hot, and it was 500 milliamps. That's still enough current to get them too hot if they don't support that. But yeah, definitely something to keep an eye on. And a normal charged, I will have to discharge the cells and charge them back to complete the cycle properly, because if they are normal charged, they're not going to get discharged because something was wrong with this cycle. So yeah, we did a live test or semi-live test. I will leave this on, even if it's not a live stream. I will leave this on, so if you're seeing this, maybe you will implement that in your head. You should not do try this at home. Try it when you receive the device. Make sure you have the proper voltage and keep an eye on the device as well. We have the temperature monitoring as well, so if the cells will get too hot during the charging process, it will stop the process. Like I was mentioning earlier, we have two temperature sensors now. The second one will cut the charging when it reaches 58 degrees or above 58 degrees Celsius. That's going to stop, and it will blink the green light showing that there's an error there, and it will, if it's a charging process, it will wait until it's cooled down. So after that it will still continue with the charging, but yeah, that's a good thing to check first, that you have the proper chemistry applied, and you should not have any issues like this with overcharging the cells. So thank you very much for watching this. I actually closed the pre-order for the batch that we have now, so a little update on the production here. I sent on Friday, I sent the final files because there were still a few things that I had to change to get right the new version. If I show you the version, if I open this one, it's full of wires because I applied the mode to it, the MOSFET mode that I implemented after I sent this file to the production, to the pre-order. Like I was saying before, I created 5 boards for testing to see if those files were right, and I found some issues. I solved them, but I had to drive some wires to make it work for the also for the menu implementation, to have the reset button transform into regular button. I had to do some changes as well, and in some of those changes I removed a resistor that was preventing the device from booting. So there were still some issues to solve and make sure that the board works fine, but I'm glad that the main changes that included the new discharge system, which is an IC that allows me to give PWM signal, and also at a high frequency at 100 and 1600 megahertz. That drives the discharging very nice. So let me actually show you this, finish this up with the discharge. I'll stop the process. So let's get back. Let's apply the lithium-ion one. Right, so you see it in the charger video that it went into discharging, and you'll see it on the screen updated as well. Before I close this video, I started before saying that we ended the pre-order for the batch, and I sent the files for those. I started talking about discharging while explaining this, but I sent the files on Friday. They are the final version. It's version 2.0 of the Megacell Charger. That's the professional version, and there are still some parts that I added, some a diode that will prevent reverse polarity when you put the main voltage in. So right now the entire device is protected for reverse polarity on the mains as well. We had a few cases, including myself, when I put the wires in reverse, and I burned all the ICs, and I wanted to make sure this does not happen with the new version, and I implemented the circuit in a way to prevent this, and with the help of the new charging ICs, that made it easier to make it and make a reliable solution to do that. So as I was saying, I stopped the pre-ordering for the batch because that's closed. I gave the numbers to the factory, but I have the new pre-order going on for the November batch. I plan to create a new batch on November. You can see that I finished most of the functionalities that are required for the Megacell charger. I'll keep working for the next couple of weeks until I get everything that that is required to test the cells properly and to use the device offline as well without having to connect it to a computer. I will be working on the Python library as well, so you can maybe use it on a Raspberry Pi or on a Linux or Ubuntu computer, not having to rely on a Windows machine to operate the device. It will not have all the functionalities that you have on the Megacell monitor, because this one has a few years now of work added into it, features in terms of features, and all the bug related issues that we have when collecting the data, making the data available in the database, read that, have multiple devices communicating with this. It got pretty advanced at this stage, and I want to offer the guys that don't use the Windows machine have an option to automate some of their tasks as well, but at the beginning it won't be so detailed as the Megacell monitor. It will be open source. You can use that to modify. You can modify the code, add all the features you want if you know some coding, but at the beginning it will not have the database with storing the cells, storing graphs and stuff like this. So yeah, that's the plan for the future. And again, if you want to get, if you did not get one, or maybe you see the video just now, or maybe you were on the fence if this device will work or not as I advertise it, I show now that it works fine, and I actually did not show you the desktop. I was showing the camera, but now you can also see the current being at 981 milliamps at discharging. This is the constant current. So yeah, all the features will work fine. The hardware works as I hoped it will work with the new ICs for controlling charging and discharging, and things are going into the right direction. So go to deepcyclepower.com, see the pre-order section for the new Megacell charger. I also have the new case. That's right here, still packed. Right, I just got it last week, but I had to finish some work on the code before implementing this one. So on the back you see here it will be the PSU with the fan, and also right here there will be the plug-in for the power supply, and here you'll be having the network. I changed a few things. I made a few adjustments to make it easier to use this and also to assemble, and this week I plan to do this one as well, to assemble, fully assemble that box with the new Megacell charger, and see if everything fits properly, and then I will go with the the 10 devices order that I wanted to make, because I want to make 10 of these devices. I also have a few pre-orders that I need to deliver of the commercial version of the Megacell charger. So that's all, guys. Thank you very much for watching. If you have any questions, don't hesitate to ask on the YouTube video, comment on the YouTube video, or go to deepcyclepower.com and write me on the chat that's available there. So thank you very much again, guys, and I wish you all the best.